Here we have a model similar to the sane demented model, except we have a new category, borderline. If 15% of your sane become borderline, when 10% go to the demented, of course that's going to leave the remaining 75% of the sane in the sane category. If the number borderline that goes sane is 20% and 10% go demented, then of course the remaining 70% will remain borderline. If 15% of the demented go sane and 15% go borderline, then of course the remaining 70% will remain demented. Now let's say that we start with 500 sane, 300 demented, and 200 borderline. Our numbers are going to look like this, following the proportions in the model. The 10% of the sane that become demented will be 10% of 500 or 50. 15% of the demented that become sane will be 15% of the 300, which is 45. And we similarly calculate the percentages for the other transitions. We see that the sane has a net loss of 40. That is, we're losing 50 and 75, gaining 45 and 40. That means we're losing 125, gaining 95, 85. Means we're losing 40. And we again calculate the gains and losses for the borderline and demented population in a similar manner. And we see then that if we lose 40 of the 500, we'll have 460. If we gain 60 on the 200, we'll have 260. If we lose 20 of the 300, well, it's pointing to those and they weren't in the camera, so let's just zoom back a little bit and see if we can see this. Again, if we lose 40 of the 500, we have our 360. If we gain 60 and 200, we have 260. If we lose 30 of the 300, we have 280. And now we are ready to calculate the percentages again, and we could continue this process as long as we wish. We can represent the process in terms of transition matrices, just as we did earlier. Remember that if 20% of the sane go borderline, 20% of the 200, and 15% of the demented go borderline, wait a minute, that's sane, borderline, and demented. So 20% of the sane, of the borderline becomes sane, 15% of the demented becomes sane. Then that leaves us with 75%. I'm not saying that right. I was going to stop the tape, but I decided I'll just go back and correct myself here. These numbers here don't have anything to do with the 75%. Let's look again. If 15% of the sane become borderline and 10% of the sane become demented, the 15 will multiply the 500 and contribute to the 260. The 0.10 will multiply the 500 and contribute to the 280. Then the remaining 75% of the sane have to remain sane. So this column has to add up to 1. Similarly, if we look at what this column means, this is 20% of the number of borderline, but this 20% being in the first row will contribute to the number of sane. So 20% of the borderline becomes sane. 70% of the borderline in the second row now will remain in the borderline. 10% of the borderline will become demented. The fact that 20% of the borderline becomes sane and 10% of the borderline become demented implies that 70% of the borderline have to remain borderline, so that we have these probabilities here. We're given these two, we determine this one. And again, this column representing what it does, the total number essentially of the borderline, has to add up to 1. And we can make a similar interpretation for the third column. 15% is the number, 0.15 will multiply the 300, which is a number demented, and contribute to the 460, which is a number of sane. So this is a number of demented that become sane. This is a number demented that become borderline. That amounts to 30%, which means the other 70% of the demented have to remain demented. And 70% of 300 goes into the 280, contributes to the 280. Goes into sounds like division, and that's not what we're talking about here. So we see that we have a transition matrix such that when we multiply these numbers by the sane, borderline, and demented, it gives us the new numbers of sane, borderline, and demented.